Welcome to this video all about motor efficiency formulas. We see the first formula here. Horsepower equals I times E, current times voltage times EFF, where the EFF is standing for your efficiency in percentage over 746. 746 is just a constant. It's a number that we're going to use in this formula. We can also transpose this formula or rearrange the subject of the formula. If you want an in-depth video on this, check in the description and I'll link a video for this. But what I should explain should make enough sense. So let's say we want to solve for I. So in other words, we want to solve for the current. How would we go about that? Well, we got to comprehend all the stuff on the top is being multiplied together. So that being multiplied together divided by the 746 equals the horsepower. Because of that, we cannot change anything in the top for this to make sense still, and we can also not change the entire thing on the top to the other side because everything on the top is being multiplied. But if you took it all as one chunk, there's nothing happening before it. Process of elimination, I'm left to having to change my 746 because that's the only thing I could change here. To change it, it's being divided by 746, so I'm going to multiply by 746, canceling that on the right side, and now doing the same thing on the left side. Now I have horsepower times 746, that is going to equal current times the voltage times the efficiency percentage, EFF. And now since these are all being multiplied together, these can be rearranged in any way. And also, we can divide any one of these. Not only that, but we can divide any grouping of these things being multiplied. So let's say we want to isolate the I. To do that, if we get rid of the E and the EFF, then the I will be isolated. So those are all being multiplied together. Now we're going to divide by E times EFF. That will cancel out the E times EFF on this side, and now we're going to do the same thing on the other side, divided by E times EFF. Okay, so now I'm going to rewrite that with I starting on the left, and we're going to get I equals the horsepower times 746 over voltage times efficiency. And that is our final answer there. So we solved for current in the circumstance of the motor efficiency. So if HP, we know horsepower times 746, we know that's just the constant in this formula, divided by the voltage times the frequency. Okay, so you saw that was pretty easy. Now we're going to solve for E. We're going to go in order here. But the thing to remember is the formula and its base, since we're going to be building everything off that. So just remember the formula for finding your horsepower. And that's going to be I times E. So let's break it down. You're used to seeing I times E next to P. If you want to find power in Ohm's law, oftentimes you have watts represented by P. P would equal I times E. So you're used to seeing pi. So just think that. You see horsepower, think HP equals, the first thing is the pi, PIE. You already have that. And then just think times the efficiency. If you want to think of something funny, think of like when you get hurt or something, you might say IEF or something. I don't know, just little things to help you remember. Things like that can really stick with you when you make up something stupid like that. Okay, so try something out like that. And then divided by 746. Couldn't think of a clever way to remember 746. I mean, you could think of whatever you want to help you. I'm just going to think of remembering the number 746. It's pretty simple, and not that many of the electrical formulas have numbers. Okay, so you don't have to remember that many numbers. Remember horsepower, I times E times F over 746. HP, you have the P, so you have the pi, PIE, you have the efficiency over 746. Okay, so I said it enough times to where now you should really have it ingrained in you. Now we're going to solve for E. And if you comprehended what I did in the last one, then you'll see what we're going to do now is going to be basically the same thing. It'll be pretty simple. Same thing. The only option we have is multiplying by 746, and that is what we're going to do because of it. On the other side, we're also going to do multiply by the 746. So now we're going to have horsepower times 746, and that is going to equal the IEF. Okay, and since there are some multiple letters, I'll do the multiplication sign. And now we want to find E. We have multiplication here, so we can rearrange these in any way. Like I was saying, we can combine any of them as well. So we can simply take I times efficiency, and we can divide that. That's going to cancel out the I, and it's also going to cancel out the efficiency. We're going to have E left over, which is what we wanted to isolate. And of course, we do the same thing on the other side. Now on the other side, we have divide by the current I over the EFF, the efficiency. That gives us now our final formula since we isolated E. So now we have E starting on the left side equals horsepower times 746. And that's all going to be over the current I, efficiency, EFF. And that will be the final answer to solve for the voltage when you have the horsepower, current, and the efficiency of a motor. All you got to remember is the 746 number, and you don't got to remember all these formulas separately. The whole point of this is that you just got to memorize the one formula, and you can easily make these from this. This is actually so simple, a lot of times you can do this in your head. If you're not good at that, then it's really easy just to do this on a sheet of paper. Either way, all you got to do is memorize one formula, and then create the other formulas from it. It's a lot simpler than having to remember all the different formulas. So now I'm going to erase these. I just wanted to keep those around for now in case you wanted to compare it to the original. But now we're going to move on. Okay, so now I'm going to rewrite the horsepower formula. So let's just do this together. Horsepower is going to equal I times E times the efficiency over that constant 746. Now, the whole point of this is we want to find the efficiency. We want to make that the subject of the formula. Okay, and well, we can imagine we're basically going to do the same thing, but we're going to get something different at the end of this. Okay, so stick around. Even if you comprehend how to do this, there's a bonus at the end of it that's going to tie into the next part of this. You don't want to miss that. Okay, so we want to isolate the efficiency. Of course, everything on the top is being multiplied. The product of that being divided by 746 is the horsepower. Therefore, we can't alter the top in any way without altering the bottom first. So let's get rid of the bottom by multiplying by 746 since it's being divided into 746, canceling that out. Then on the other side, we do the same thing, multiply by 746. We're going to get the horsepower times 746, and that's going to equal the I times E times EFF. Now we want to isolate EFF. Again, we can take any combination of these and we can divide, but we still have to keep the fact that it's going to be divided by a grouping of these things, which could be spelled IE, which is really I times E. So we're going to do divided by I times E. We're going to cancel out the I, we're going to cancel out the E. We're going to be left with the efficiency, which is what we wanted. And then of course, we're going to do the same thing on the next side. We're going to divide all of that by the I current and the voltage combo, so I times E. Now rewriting that starting on the left side of the formula with the efficiency, we have efficiency equals horsepower times 746, and that's all going to be over the current times voltage. There's our final answer for finding the efficiency when we have horsepower, current, and voltage of a motor. Okay, so now we have the final formula for efficiency, and from here we can understand that efficiency is the output over the input. That also tells us to find the input, we do the current times volts. So now we know that we're working with what could be called volt amps, we're not going to call this watts because there could be a power factor, and that's the whole point of doing current times volts and also labeling it as volt amps. Okay, I'm going to have a separate video for power factor, and that'll be a great learning experience. It's pretty simple, so look out for that. And now we can understand why the efficiency is a percentage, because it is simply a ratio of the output over the input. So in other words, we could compare this like if we had a test. We got a 9 out of 10 on the test. We plug in 9 out of 10 in our calculator. We're going to get 0.9, which in other words is 90%. It's like saying, okay, you have a 90%. So same thing, if we had our output was 9 amps and our input was 10 amps, we'd see that we have a 90% efficiency value for that motor. So now we know not only that efficiency equals the output over input, meaning that's the ratio. So for example, let's say we want to find the output. Well, in this case, all that we do is we'd multiply the input here to get rid of it, which means we'd have to multiply the input on the left side as well. And now the right side, the input would cancel out. So now we're left with, if we write output on the left side, output equals efficiency times the input. Okay, so now what happens if we want to find input? Same concept. Okay, so again, we can't do anything to the output. It's the beginning of the division or the top of that fraction. And the efficiency is all by itself. The efficiency and output, they're all existing by themselves. So what can we do? Well, we have the input being divided into, so we can multiply input. Do the opposite. So instead of divided into input, now we have multiply into input. We're going to now cancel that out. And on the other side, we're going to do the same thing. We're going to have multiplied by input. Now this might seem kind of weird because we're trying to isolate input, and that's what we're moving. But that's the only choice that we have. And it's a very common thing when you're going to be transposing these formulas. You're going to do this a lot. So we're going to have the efficiency now times input. That's going to equal the output. Okay, so we already figured out the output. We already know that. But now we want to isolate the input. Remember, these can be rearranged any way. So we have efficiency times input. Could very well say input times efficiency. Either way, we can get rid of the efficiency simply by dividing the efficiency. Okay? That gets rid of it on the left side. But on the right side, we have the output divided by efficiency. So now to rewrite that final formula with the input all by itself and neat, we have input equals the output, and that is over the efficiency. And that is your final formula for your input. So just like before, we memorized one formula and we got the other ones out of it. We have now efficiency. That formula makes perfect sense because we can make sense that the efficiency of something would be the output over the input. Like I was explaining, you have 9 amps out, you put 10 amps in, 9 out of 10, you have 0.9, 90%. So that's how you get a percentage, okay? And therefore, we can transpose everything like we did. We see the input is the output over the efficiency, and we see the output is the efficiency times the input. Now we're going to be looking at some questions. We have a 5 horsepower motor running at 230 volts. It is single phase. It draws 24 amps and is 80% efficient. Okay, so when it's saying it's drawing 24 amps, that's the input. Okay, that's not what the output. Another thing, we have single phase, but we wouldn't really need to know that unless we didn't have certain information. Like if we had our horsepower and our voltage and we had our single phase, we could go to the motor table. I think it's 430.248. And yeah, it is for the alternating current single phase, 430.248. And then for 3-phase, you have 430.250, just in the same opening next page over on the right page. Okay, so if you didn't know how to read that table, they tell you directions, but there's the horsepower on the left side, and then you have your volts above that, and all those numbers that you see are your amps. So read the top of it, full load current in amperes, single phase alternating current. So it's good to know that, but it's good to also know that they're going to throw in things to throw you off that are not necessary or just unnecessary things. So you got to kind of know your stuff and know what is unnecessary information, because that's just real life. Okay, especially if you have a customer, they're going to be telling you a bunch of stuff that you don't need to know. You're going to have to know how to filter through what's actually important to get the job done. And that's kind of what they're doing with these questions sometimes. Okay, so now we can think about this logically, and then I'll do the formulas after if that makes more sense to you. But logically speaking, we have 24 amps in. We know that's the input, but we also have 230 volts. Okay, don't forget that, because we don't just have 24 amps in. We could have 24 amps and 120 volts, and, you know, the voltage is obviously going to change the input. Again, the input is going to be volt amps. So because of that, that gives us insight that if we want to find our actual input for the moment, 230 times 24 is going to give me 5,520. But we can't stop there because we have an 80% efficiency value. So we're going to times that by 0.8. Now 5,520 times 0.8, 80%, is going to give us 4,416. That's going to be in volt amps, and that's going to be giving us the output. Okay, so there's our final answer for question number 1. We want to find the current of a motor with 5 horsepower, 240 volts, and a 75% efficiency rating. Okay, first I'm going to think about the horsepower formula, and how that is going to be I times E times the EFF, efficiency, over 746. Okay, and I want to find current, so I know that if I want to now rearrange this, all I got to do is get rid of the 746, and now I have that on that side. Now I want to further isolate the I, so I'm going to do this a little sloppy to kind of show you how you do it in real life a little more. So now I have E and EFF. Now I'll get rid of the E times the EFF combo. That'll get rid of all this, and now all that is going to go over E times EFF. Okay, so now we have everything canceled out besides I. Now I'll rewrite it with I on the left side. I equals horsepower times 746 over E times EFF. Okay, it took a little while. If you find it easier to memorize all the formulas, so be it, but there's going to be a lot more formulas you're going to have to memorize if you go that approach. Of course, that's not the answer. That's the formula to find the answer. Okay, so now I'm going to take that and I'm going to plug everything in. Now we have the horsepower, which is 5 times 746. Okay, that's just the constant. And that is going to be divided by E times EFF. So the voltage, 240 volts, times the efficiency, which remember is a ratio, which is a percentage, and we had 75%, so we're going to have 0.75. Now you're going to first multiply the top, and then you're going to multiply the bottom, and you're going to then divide both of those. 5 times 746 equals 3,730. 240 times 0.75, which is also 75%, is going to be 180. Okay, now we're going to get 3,730 divided by 180, and we're going to get 20.72 repeating amps, and you could always just round that, and you could say 20.7 amps, or 20 amps, whatever it is, that is your final answer there. And I am explaining stuff, so it's going to take a lot longer, and you could do this a lot quicker on an actual test. And if you had a test and you knew that you're going to have horsepower questions, well, one of the first things you could do is on a certain section of the paper, write out your formulas for the horsepower and the different transcriptions that you might get from that when you want to find the horsepower and the current and the voltage and the efficiency. And then from there, your efficiency formula, which is also another way of saying efficiency, is equal to output over input, and then you can get those two other formulas from there. So if you knew you had a test on that, you could write that, and in the beginning of the test, you could always do your Ohm's Law formulas as well. If you want to know a trick on how to write down all of your Ohm's Law formulas, I'll have a link for a video about that. It's really simple. You need to know 4 formulas, and you can get all of the Ohm's Law formulas from that. I actually teach that in a way where you don't need to know actually how to rearrange the subject of a formula, and I teach it in a much simpler, more comprehensible way, and it's kind of a funny lesson too, but it really sticks with you, so I recommend that. Okay, so now we have the answer for question number 2. Okay, next question, we're going to be solving for horsepower, and we have a motor with 12 amps, 240 volts. It is single phase, and it has an 85% efficiency rating. And now this one's pretty convenient because we know our horsepower formula pretty well now. We have the HP, think PIE, we have the P times I times E times the EFF over 746. So now we can just simply plug in the numbers. We're going to get the 12 amps times the 240 volts times the 0.85, 85% efficiency rating over the constant 746. And remember, we're going to multiply all this, get a final number, and then we're going to divide that by 746. 12 times 240 times 0.85 is going to give us 2,448 over 746. And that is going to give us 3.28 horsepower for our final answer. Okay, next question. We're looking at the full load current. We have a motor with 5 horsepower, 240 volts, and a 60% efficiency value. We're used to full load current probably in the codebook, in the table like I mentioned. But right now we're just going to be thinking about full load current as what we solve for as current. So again, I'm going to start with the horsepower formula. You probably already have this written down. That's good practice. Horsepower is I times E times EFF over 746. Okay, we want to isolate the I. So I'm going to start by getting rid of the 746 on the right side. And then I'm going to then get rid of the E and the EFF combo. And then again, I'm going to have everything on the other side now divided by E times EFF. Okay, so in other words, the formula I'm going to be working with for current, which I already just did, but again, good practice. We have I equals HP, horsepower, times 746 over E times EFF, voltage times efficiency. Okay, now that I have the formula for the question that we're working with, I'm going to plug in what we have. I have 5 horsepower times 746 over 240 volts, and that is going to be multiplied by the efficiency value of 0.6, or you call it 0.60. Okay, you don't need to put the 0 after, of course. We're going to multiply the top, and then we're going to multiply the bottom separately. We're going to get each one of those separate answers, and we're going to divide them accordingly. Okay, 3,730 divided by 144, we're going to get 25.9 amps since we're working with the current, and that's going to be our full load current for this answer. Next question, we're trying to find the efficiency rating, and we have a motor with 24 amps, 5 horsepower, it has 208 volts, and it is single phase. Let's start out with the horsepower formula. Horsepower equals I times E times EFF over 746. I want to isolate my EFF, getting rid of the 746 first on both sides, and then I'm going to isolate my EFF by getting rid of the combination of my I times E by dividing those here on the right side. Then the left side, same thing, divided by I times E combo, leaving the EFF on the right side. Now we have our formula we're working with. Our efficiency equals our horsepower times 746 over the current times the voltage. Okay, now that we have the formula that we're working with for this question, let's plug everything in. Okay, so we have 5 horsepower times the 746. Okay, and that is over the 24 amps times 208 volts. Multiply the top, then multiply the bottom, and then divide those separate answers. 5 times 746 is going to give us 3,730. And then 24 times 208 is going to give us 4,992. 3,730 divided by 4,992 is going to give us 0.74719. It keeps going. It's a big decimal. We're going to round it up to 0.75 as our efficiency. So in other words, since our efficiency rating is a percentage, we're going to call that 75% as our efficiency. And that's our final answer. Okay, next question. We're looking for efficiency again. We have a 5 horsepower motor, 230 volts, it's single phase, and 22 amps is what it is drawing. Okay, so we know that the efficiency is going to be the output, and that is going to be over the input. So we know the input, we have our 22 amps and our 230 volts, but the problem with this is we obviously don't have our output because we don't have our efficiency. Okay, so there's a missing link there. So we're first going to actually have to find out that efficiency formula that will work with the information that we have here. So again, I'm going to think about the horsepower formula. I have my I times E times EFF over 746, okay? And I want to isolate my EFF. So pretty simple. I'm going to multiply my 746 and get rid of it. And then I'm going to divide by my I times E combo, getting rid of both of those. And also then doing that now on the other side. Leaving my EFF. So rewriting it, efficiency formula is my horsepower times 746 over my current times voltage. And just like before, we're plugging everything in. Okay, so we have the 5 horsepower times the constant, 746. That is times the current, 22 amps, times the volts, 230 volts. Multiply the top, multiply the bottom, divide them. Okay, 5 times 746 gives me 3,730. 22 times 230 gives me 5,060. 3,730 divided by 5,060 gives me 0.74. But it'd be good to rewrite that as a percentage. So I'll call that 74% as my efficiency rating. And that is the final answer for this question. Okay, now very similar to the last one, I'm going to keep the formulas there. We're going to find the efficiency of a motor, 3 horsepower, 230 volt, single phase with 18.7 amps that it is drawing. Plug everything in. We have our 3 times the 746 over the current times volts, so 18.7 amps times the 230 volts. Again, multiply the top, multiply the bottom separately, divide them. 3 times 746 is going to give us 2,238. 18.7 times 230 is actually going to give us 4,301 with no decimals. 2,238 divided by the 4,301 is 0.52. So I'll rewrite that as the 52% as the efficiency rating for this question. The next and final question, number 8. The last one should have said number 7. I forgot to erase the 6. Okay, we're looking for horsepower. We have a motor that takes 20 amps at 240 volts with a 75% efficiency rating and it is single phase. So this is the last time we get to hear me do the horsepower formula. Okay, so let's cherish this. Horsepower equals I times EFF over 746. Okay, and since we're solving for horsepower, that is our formula. So now we just plug in everything that we have here. Okay, we have 20 amps times our 240 volts times the 0.75 for the 75% efficiency rating. That's going to be over 746. Multiply the top and then divide that by the bottom, which is just 746. 20 times 240 times 0.75 equals 3,600. 3,600 over 746 gives us the answer 4.83, and that is our horsepower. That's the final answer for the final question, and that's it for this video. So if you see, it's pretty simple. It's very straightforward. A lot of it makes logical sense, and you just gotta memorize the one formula basically, which I've gone over enough times, okay? But then you can also remember the other formula, that your efficiency is your output over your input. And then with that, you can, again, create your other two formulas from that. Thanks for watching. Give the video a thumbs up if you enjoyed watching it and if you learned something. If you have any questions, leave those in the comments down below. Feel free to add any comments, critiques, things that you maybe just didn't understand, or maybe you thought something was incorrect but you're not quite sure. If you want to personally contact me, then contact this email right here. And that's it for this video. Until next time, take care. Goodbye.